This is a video on the verb summarise. The question is, summarise the main steps involved in seafloor spreading. 3 marks. The verb summarise means express concisely the relevant details. So in other words, provide details in a concise manner, in a brief manner. So let's try and answer this in the context of seafloor spreading. Best way to start off a response like this is by writing a general introduction. So you can start off by writing seafloor spreading is the process by which new oceanic crust is formed at mid-ocean ridges via volcanic activity. So oceanic crust, as the name suggests, is crust beneath the ocean. Mid-ocean ridges, so underwater mountain ranges, and typically there you'll find volcanoes, volcanic activity. You can then write the process. So this process involves the following steps. So you've told the marker in general what seafloor spreading is, you've understood it, and you're going to now tell them what they are, the main steps involved. So let's use the numbering system. Let's go 1, magma rising. So the first step, magma rising, so hot magma rises through the mantle rises from the mantle, I should say, through a crack in the oceanic crust at mid-ocean ridges. Okay, so magma rises through cracks in the oceanic crust at mid-ocean ridges. That's step 1. Step 2. Step 2 is development of new crust. So just as hot candle wax solidifies when it cools, same thing with magma, right? So you can write as magma reaches Earth's surface, it cools and solidifies. Forming new crust. So you get new crust through the solidification of magma. And the new crust in turn, so new crust in turn moves away from mid-ocean ridge. Okay, that's because as the magma keeps rising up, it cools, solidifies, and moves away from the mid-ocean ridge. Step 3, the final step, is seafloor spreading. Okay, so you can write as the crust moves away from ridge, carries away rocks with it, creating a symmetrical pattern of magnetic stripping on ocean floor. So magma contains magnetite. Magnetite's an iron-rich material, and magnetite behaves like a little compass needle. It's got a magnetic orientation. So as the new crust moves away from the ridge, you get symmetric patterns of symmetric patterns of magnetic stripping, in other words. So suppose you've got magnetite along, draw another sketch. Okay, mid-ocean ridge is here, use a different color. Okay, suppose you've got strips here. So new crust forming, and they contain magnetite. The magnetite is oriented in the north-south direction, as follows, and then the one next to it, because it's symmetric, okay, they will have the same orientation, and these will be in the south-north direction. Okay, so the magnets, the magnetite, the direction of magnetic orientation will be flipped, okay, and that repeats. It's an alternating pattern, south-north, north-south, etc., etc. About the mid-ocean ridge. It's symmetric. Okay, and this indicates that Earth's magnetic orientation is also flipped over hundreds of millions of years, as we now know. So that's the idea of C4 spreading. It involves three main steps. You've got magma rising, then it cools and solidifies, and it pushes away from the mid-ocean ridge. So 3 steps there. Question for you to do: summarize the main steps involved in the creation of an earthquake via transform boundaries. 3 marks.